We're still continuing on with 3.5, and now we're going to talk about inverse variation. Before, when we talked about direct variation, we said that if the y went up in value, so did the x, or if the x went up in value, so did the y. Or sometimes with direct variation, if one went down, the other went down. In inverse variation, we have the opposite effect. So we would have, if the x went up, the y will go down. And it is written like this: y equals some constant over x. And it could be said y varies inversely, or we could say it's inversely proportional. And if you hear those two statements when you're reading a story problem, then you're going to want to write it like this equation right here. Oh, and by the way, just like with direct variation, you can have an nth power. So if it said y varies inversely to the square of x, you would have this situation where n would be 2. So be aware of that. Here's an example. A company has found that the demand for one of its products varies inversely as the price of the product. When the price is $6.25, the demand is 400 units. Approximate the demand when the price is $5.75. So there's two parts to this. The first part, we know that it's inversely proportional or inversely. So we were going to write out X is your demand and P is your price. So we have X equals K over P. So we know that X is 400 when P is $6.25. So we will replace the X and P with that and solve for K. And if you multiply both sides by $6.25, you will find that K is $2,500. So now we need to find out what it costs, what the demand is when the price is $5.75. So we're going to replace the P with that. And notice that the demand is 435 units. If you think about economics for a second, you know that as the price goes up on something, usually the demand goes down. So that's this situation here.